Do now. Any volunteers?
The first is gonna be negative.
Attention, attention.
The first one will be negative infinity, comma infinity.
Domain equals. Say it again.
Negative infinity, comma infinity.
Comma infinity.
And then it's gonna be negative infinity, comma infinity.
For this one. Alright, so we got negative infinity and positive infinity. What
And
about
then
this one?
you're gonna have a negative infinity, comma 0. That leaves you in
Do I have a bracket or parentheses right here?
parentheses.
Parentheses. Why parentheses? Jamante.
Because the line never changes 0.
Right, because x can never equal 0, it'll be undefined. So that's why we have parentheses. Keep going.
Union,
Union,
open parentheses,
Open.
0,
0.
comma, 0, comma, infinity.
How you say it right?
For the next one.
Oh, for the next one? Alright.
It's not.
What's this one?
Is it gonna be a bracket 0, or is it gonna be a parentheses?
Can x equal 0?
No.
No, it's gonna have to be, okay, it's
Are you sure? I'm just asking.
Yes, I'm sure.
Everybody agree with that?
I don't even know. I have no idea. I got a bracket.
You got a bracket. Can you add the square root of 0?
No.
Yes,
Yes, because the square root of 0 is 0, right? You get a
So
value.
it's gonna be a bracket.
So you can have a bracket. X can equal 0.
I thought we were going to use bracket for greater than the less than.
Infinity.
Right, that means the
Alright,
same thing.
does everybody understand this? I need to go over this.
Go over
Where
it
you
again.
going?
Where you getting 0 from?
0. Alright. Dealing with the fraction. Domain is your set of all your input values. These are values that I can input into this equation and make it true. So the reason why we go from negative infinity to 0 is because I can plug in any negative number all the way up until I get to 0. If I plug in 0 in the denominator, is this a true statement with 0?
No.
Why not? Because it's what? It's undefined. So that's why it goes from negative infinity to 0 without a bracket, because x cannot equal 0. Then the union, I'm going to have 0 again with a parentheses because it can't equal 0, but I'm going to positive infinity because all the positive numbers, all real positive numbers I can plug in and get a true statement. You got that? Everybody agree with the rest of these?
Yeah.
All right. Like you reminded me of the All right, can somebody read the FQ for me for today? Raise your hand. Donovan.
How do we determine if y is a function of x?
All right, how do we determine if y is a function of x? All right, the first thing we need to learn first is a term called a relation. All right, and a relation is a set of ordered pairs where the first component hope y'all writing this. Where the first component are the input values and the second component are the output values. And I hope I spelled everything right. All right, so I just said a mouthful right there. First of all, let's break this down. What are ordered pairs?
Like,
X,
comma,
Y.
something.
Right, something that looks like this. We have x,
Comma,
comma,
Y.
y, right? All right, so I have a set of ordered pairs, which means I have more than one, but I have a set. And the first component, my x, are my input values.
And Y.
And my, so,
Y is your output.
and y is my output values. Basically what I'm saying is if I have an equation, whatever value I input for x, my output is y, which is my answer. All right, everybody got that? So another way of saying this is my x are my independent variables, and my y are my dependent variables. Anybody can tell me why is that? Why would y be a dependent variable?
Because it depends on the x.
Because it depends on the independent variables, right? All right, so with that said, we're going to go into what is a function. A function is a relation that assigns to each input that assigns to each input number exactly, and emphasis on exactly, exactly one output number. Alright, so what this is saying is that whenever I have a set of ordered pairs, the input numbers I have can only be assigned to one output number. If I have one input number assigned to more than one output number, it's not a function. Alright, so quick example of that.
1, 2, 3, 4, 5, 6.
Alright, if I had the ordered pairs, the set of ordered, if I had 8 and -1, if I had 9 and -3, and 10, -1, and 13 and 5.
Not a function.
Alright, hold on. Alright, so what are my input values? What are all my input values?
8, 9, 10, 13.
Alright, so we're going to say x. I'm going to do a map to show this. My x was what? 8,
8, 9,
9,
10,
10,
13.
and 13, right? Alright. What are my output values?
-1, -3,
-1.
Negative.
Now, -1, -3.
-1.
Alright, now, when I'm writing my output values, if I have the same output value twice, I only need to write it once. Okay? Alright, so I got -1 twice, so I'm just going to write it once. And I got -3, so what else is left? 5. Alright, now remember, for it to be a function, the input value, each input value has to be to exactly one output value. Okay? Alright, so input value is 8. What's the output value? -1. 9. -3. What about 10? 10 is the -1. And 13? 5. All right. Is this a function?
No.
Who all says no? Who all says yes? Who all doesn't know? So everybody thinks this is not a function. All right, one more time. A function is a relation that assigns each input number to exactly one output number. These are each of my input numbers, right?
Oh, that's a function.
These are each of my input numbers, right? Does 8 go to just one number?
Yeah.
Does 9 go to just one number?
Yes.
What about 10? Does it go to just one number?
Yes.
What about 13?
Yes.
All right, so I'm gonna ask that question again. Is this a function?
Yes.
Why is that?
Because every input number goes to exactly one output number.